Hello. In this video, we're going to take a look at performing some basic mathematical operations on signals. So one of the basic operations is to do time shifting. So we might perform a time shift of a signal x of t by some value capital T. So we define a new signal, phi of t, as given by x of t, our original signal, minus capital T. If t, capital T rather, is positive, the signal is shifted to the right. And we often refer to this as the signal is being delayed. If capital T is negative, then the signal is shifted to the left, and we say that the signal is being advanced in time. To show this a bit more concretely, let's take a look at a graphical example. So let's say our signal x of t is shown up over here. If we perform a time shift where capital T is positive, then we're doing phi of t, our new signal is x of t minus capital T, t being positive, then we are going to shift our signal to the right relative to the original signal by this value capital T. So we're actually delaying the start of that signal by capital T. If we are going to do a shift where capital T is negative, then x of t minus capital T, t is negative, so this becomes x of t plus capital T, then this is going to be the signal shifted to the left. And so now the signal is actually starting before the original signal, so that's why we refer to it as an advance. So let's take a look at an example. Let's say we want to sketch x of t minus 5, where x of t is this original signal over here. Well, one simple way to think about doing this example is to essentially rewrite the time axes. So our original signal we can define as x of t prime, and this axis here as t prime. And what we want to sketch is x of t minus 5. So we're essentially doing a transformation of our time axis. We want to go from t prime to t minus 5. So for our new signal, if we want to sketch our new signal phi of t, well, let's take a look. Our variable t is simply going to be given by t prime plus 5. So in this particular case, if this t prime value here is equal to 1, then t is going to be equal to 6. Here, if t prime is equal to 3, t is going to be equal to 8. So as a result, if I were to plot now phi of t as a function of time t, then my signal is going to go from 6 to 8. So at time t equal to 6 and at time t equal to 8, I'm going to have a signal that looks like this, where the maximum value here is 3. So you can see indeed that my signal has been shifted to the right, or effectively it's been delayed. Another important mathematical operation on a signal is to do time scaling. So in time scaling, you're essentially going to multiply the time axis by a factor a. So the scale that you perform will depend on the size of a. If a is greater than 1, then we refer to the fact that the signal is being compressed by this factor a. If a is less than 1, then we say that the signal is being expanded by the factor of a. And of course, time t equal to 0, the origin is a point that doesn't change under the scaling. So again, let's look at this graphically. So consider our signal x of t, which is shown over here, and it's defined between capital T1 and capital T2. So if we now scale it by 2, by a factor of 2, so now phi of t, our new signal, is x of 2 times t. A is greater than 1, so we're actually doing a compression. So our time that was t1 here is now t1 over 2, and our time that was here t2 now becomes t2 over 2. So that corresponds to the compression. The signal is actually being compressed in time. On the other hand, if we define our new function phi of t to be x of t over 2, our factor is now half, that means we're doing expansion. So our time signal here t2 winds up going to 2t2, our signal here t1 goes to 2t1, and so you can see now that the signal has been expanded in time. Let's take a look at an example. So again, we have to sketch phi of t, which is equal to x of 0.5t, where x of t is shown in the figure over here. So again, what we can do is to relabel the axes and say, here's an x of t prime. This is my t prime axis. And I want to get a sketch between t prime and t, where I essentially have t prime being half t. So as important functions, or as important points here, over here is the point t prime is equal to 2. That would map to t being equal to 4. If I take a look at this point over here, that's t prime is equal to 4, that would map to t being equal to 8. And then if I look at this point here, that's t prime is equal to 6. That maps out to t equal to 12. So if I then want to finally plot phi of t as a function of t, then my important points are going to be 4, 8, and 12. I have here 4, 8, and 12, and I'll have this signal over here. And again, this maximum value is 3. So in this case, you can see that I am going to expand out in time my signal because it's occupying a total duration of 8, whereas the original signal occupied a total duration of 4 units. The last signal operation that we'll take a look at is time reversal. So time reversal of a signal x of t is defined by the new signal phi of t, where we simply replace t by minus t. So phi of t is x of minus t. And you could think of this actually as scaling, where the factor is equal to minus 1. So as an example, if I have x of t shown by this function over here, e to the minus t over 2, when I do time reversal, I'm going to have x of minus t as this function right over here. So I've just essentially done a reversal of the time axis. So let's look at one final example. I want to sketch phi of t, where in this case x of t is shown over here, and phi of t is x of minus a half of t minus 5. So in fact, I'm doing time reversal as well as a shift. So again, we start as before. Let's define this as t prime. And what I want to look at is a mapping between t prime and t. So in this case, t prime is going to map to minus 0.5 t minus 5, or effectively, I'm going to have t prime plus 5 maps with minus 0.5 t, or t prime plus 5 times minus 2 is my mapping for t. So if I take a look at key points in time of my original signal over here, when t prime is equal to 2, I'm going to have t is going to be equal to minus 14. When t prime is equal to 4, I'm going to have t is equal to minus 18. And when t prime is equal to 6, so this point over here, I'm going to have t is equal to minus 22. So if I want to sketch now phi of t, right, the key points that I have to take a look at are going to be minus 14, minus 18, and minus 22. And so what I'll have for my signal is the following one. So this would correspond to signal that's been expanded in time and in which I've also created a shift. So if you have any questions, please send me an email.